Hello class, this is a video tutorial on factorial notation. In some previous examples seen so far, there were scenarios where objects are or are not repeated or replaced. So let's go through just a quick set of examples here. I want you to see if you can answer these yourselves. How many 4-digit PIN codes are possible? Well, as we've seen from these, the options that we have were, well, the digits 0 to 9. And then from these, let's see if I can show it. Yep, there we go. In the first digit, we could have 10 possible selections. The next digit, we could have another 10 possible selections, and then another 10, and then another 10, which in total gives us 10 to the power of 4 total different PIN codes. In this example, we had repeated options because just because, let's say, this was a 9, it didn't stop us from making the second digit also a 9, so we could repeat the options. Here's another one. How many different ways can a race finish with 5 competitors? A race with 5 competitors finish? Well, in this one, we have the different positions we could take. We could take first place, second place, third place, and so on. In first place, 5 different people could come first. But if someone comes first, that means in second place there are only 4 options left. And so on. In third place there is only 3 options left, and so on. So we had 5 times 4 times 3 times 2 times 1. In this example, there were non-repeating options because it's impossible. So let's say Adrian comes first. It's impossible for Adrian to come second as well. Hence why there are only 4 left. Here's another example. We have a deck of 8 cards, and each of them are numbered 1 through to 8. And we shuffle them. An 8-digit number is to be formed by selecting a card at random from the deck. How many different numbers can be made if each card is returned after being selected? Well, let's take a look. Here are the 8 possible digits we could pick from. In the first digit, we could pick 8 different possible cards. Because we put it back into the deck and randomly select it again, we could pick 8 again. And I'm pretty sure you're getting the idea that it's possible to get 8 to the power of 8 different digits formed by this deck of cards. This is again an example of repeated options. Because, for example, let's say the first digit was a 1. If we shuffle that card back into the deck, it's possible for a 1 to show up again. Here we go. And in comparison to that one, we're going to do the exact same thing, but this time we're not going to put the card back into the deck of cards and leave it out. Well, that means here are the 8 possible digits. In the first one, there are 8 possible cards. But once we picked 1, that means on the next digit, we have 1 fewer option available. And the next digit, we have 1 less again. And this continues until we're down to the last digit. This is an example of non-repeating options. I really hope you get this idea that we have repeating options and non-repeating options. As seen above, for scenarios with repeating options, index notation can be used. So here we have repeating options, and we could have index notation 10 to the power of 4. In this one, we have repeating options 8 to the power of 8. But for non-repeating options, the notation that can be used is known as factorial or factorial notation. I'm not sure exactly which one's used, but you get the idea. Factorial notation or factorial notation. We have some number n with this exclamation mark. What it means is we start on the number n and we multiply by one less than that number, and then one less again, and then one less, and so on and so on and so on until we get to 1. So for example, if we have 5 factorial, that means we start on 5 and we multiply by 1 less, 5 times 4 times 3 times 2, all the way down to 1. If we had 10 factorial, we start on 10 and we multiply down all the way to each integer down to 1. So 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, and 1, and you get the idea. Now there's one little point that we need to just accept for now, that 0 factorial is 1, and I'll show you a proof of that in a different video. So actually, just so we're clear, for this one, since it's 5 times 4 times 3 times 2 times 1, this is equal to 5 factorial. This one here, since it starts on 8 all the way down to 1, this is 8 factorial. We'll do one last example here. How many different arrangements of a regular deck of cards are there? A deck of cards has 52 possible options. So on the first card, we could have 52, so we pick it and place it there. The next option, well, since we've placed one card here, there's one less card for the next option. In the next option, there's one less again. The next one, there's one less again. And this continues all the way down until times 3, times 2, down to the last card. And this is an example of 52 factorial. So I hope that gave you an insight into, just before I go, you just press that button first. So for example, if you want 5 factorial, you press 5 and then that button, and it comes out as this. But in essence, I hope you understand when we use this notation, factorial notation. It's when we have a non-repeating set of arrangements. So I hope I gave you an insight into this. Hope to see you in the next video, and best of luck.